I've started objective 3 with an update to my unit circle from the last time you saw it. The last time you saw it, we had completed the 30-degree reference angle in quadrant 1, the 45-degree reference angle, and the 60-degree reference angle in quadrant 1. And I told you back then that you really only need to know those three because in the other three quadrants are the same reference angles. So they're going to end up using the same ordered pairs, except you're going to have to watch out for the signs. So for instance, if you take this 30-degree angle that's in quadrant 1 right here with the yellow terminating ray. If you go over to quadrant 2, this would be the same angle. It's not 30 degrees, it's 150 degrees, but the reference angle is 30 degrees, so the ordered pair would be the exact same ordered pair with the exception of every point in quadrant 2 has a negative x value, but a positive y value. So if you just continue that pattern along through the entire unit circle, and the way I have it color-coded, you can just follow the different colored lines and you know which reference angles match up. So all you have to do is make sure you follow the appropriate signs and you're going to be fine. So go ahead and complete that unit circle if you haven't. You may have done it in class. Now on the back of my unit circle, I have a few things that you're going to need for worksheet 3. Here's the representation of the 45-45-90 triangle. I did it with the A and the A and the A root too, but if you standardize it to where it's placed in the unit circle, the radius is always 1, and so therefore in blue are the values after it's been standardized to where it has a radius of 1. You should have these in your notes. Hopefully you're practicing them every day, if not every other day in class, because you really do have to commit these 3 triangles to memory. Now, something else you know from prior classes, the quadrants with positive trig ratios. In the first quadrant, everything has a trig ratio. All trig ratios are positive in this quadrant. And then sine, tangent, cosine. One of the common ways to remember it is all students take calculus. That's not true, but it's one way to remember it. It's just an acronym. All students take calculus. Or actually, it's a mnemonic memory device. Now, another one you already know is all the trig functions, sine, cosine, and tangent. But here's one you might not know, and you're going to need it for worksheet 3 today. Another way to find sine, in addition to opposite over hypotenuse, is by using the ratio of y over r. You may have heard that, maybe you haven't, but you're going to use it today. Cosine, x over r, and tangent, y over x. And with that, that's all we're going to do in updating this unit circle and the common trig information that you need to know. There's some other stuff you're going to need to know, but not yet, so we're not going to worry about it. Task number 1 for objective 3, finding one positive and one negative coterminal angle for the given angle theta. So if theta is 120 degrees, I've already marked it, positive 120 would put you about right there. Now what we mean by one positive and one negative is just what if you went around one entire circle, one revolution? That would be adding 360 degrees. So 120 plus 360 would be 480 degrees. Now, what if you started back at that 120 degree angle again, but this time you went the other way, 360 degrees? So what if you subtracted 360 degrees? So 120 minus 360 equals negative 240 degrees. And that's what we mean by coterminal. For this one, I started with negative 300, so you can see when we go negative, we're going to start here, and we're going to go clockwise, 90 degrees, 80 degrees, 270 degrees, and I'm going to end at negative 300, about right here. So again, it's the same idea. What if I went 360 degrees in the positive direction? So negative 300 plus 360 equals 60 degrees. And what if I went negative 360 degrees by just going around in another circle? So I start at negative 300 and I subtract 360 and I'm at negative 660 degrees. So fairly simple little task right there. Okay, task number 2. There's a lot of instructions. It's real wordy, but it really isn't that bad. If we had a reference angle, if we had an angle of 330 degrees. First thing, let's figure out where that is and identify the quadrant of the terminating ray. So 330 degrees would be, start here, it's positive. So 90, 80, 270, 360 would be going all the way around, but we didn't make it all the way around. We only made it 330 degrees. So we almost made it around, but we didn't. So we already know that we're in quadrant 4. Now, what's the reference angle? Well, if this is 330 degrees, remember reference angles are always off of the horizontal axis. So we're going to think of this. We were 30 degrees short of making it all the way back up to this x-axis right here. So the reference angle is 30 degrees. Now, remember how I said those special right triangles are really important? Well, now all I want is the sine of 30 degrees and the cosine and the tangent. So that's where you go back to these. You key in on the 30-degree triangle that's probably somewhere in your notes, at least once, probably twice. You key in on the 30-degree angle, and you remember sine is opposite over hypotenuse, so 1/2 over 1 is just 1/2. Cosine of 30 degrees is adjacent over hypotenuse, so it's √3 over 2 over 1, so it's just √3 over 2. And tangent of 30 degrees is opposite over adjacent, so it's 1/2 over √3 over 2. So it's 1/2 over √3 over 2. Now, from here on out, we're not going to do the long division every single time. The 2's are going to basically cancel each other when we do, so that's going to be 1 over √3. And when I rationalize this, it makes √3 over 3. Now there's one more thing we need to check. Remember, we were in quadrant 4. This whole thing started with this 330 degree angle, which is in quadrant 4. And here are my 3 trig functions, but I have to remember what's positive and what's negative. So all students take calculus. So my cosine value is the positive value, but my sine and my tangent value are negative values. So you need to put a negative right there and you need to put a negative right there. My next example is similar to the other one. I'm now dealing with an angle of negative 225 degrees. Theta equals negative 225 degrees. So the first thing we have to figure out is where is that? So it's negative, so we need to go clockwise. That would take us to 90 right there. That would take us to 180 right there. And 225 would take us about right here, because it wouldn't get us all the way to 270. So now I know exactly where I am. I'm in quadrant 2. But what's my reference angle? One more time, reference angles are always off of the horizontal axis. So we went to 90, we went to 180, and we went past 180 by 45 degrees. And that tells us our reference angle is a 45-degree angle. So all that does is it takes us back to our chart with a 45-degree angle. And the sine opposite over hypotenuse is square root 2. We're right here, 45-degree angle. Root 2 over 2 over 1. Sine is opposite over hypotenuse. So root 2 over 2. Now cosine is the same thing on a 45-degree angle. Adjacent over hypotenuse, and remember the hypotenuse is 1. So that is just root 2 over 2. Now tangent is opposite over adjacent. Well, they're the same thing. So root 2 over 2 over root 2 over 2 would simply be 1. Now, the only thing we have to worry about is which ones are positive and negative. So I know I'm in quadrant 2. All students, so that tells me sine is the positive one, which also tells me cosine and tangent are negative. Now let's go down to task number 3. What if we tried to do the same thing, but we didn't land? Our terminating ray actually landed right on an axis somewhere. Well, we have to do our analysis a little bit different. In the unit circle, the radius is always 1. So let's go back to those points again. Remember, this would be 1, 0. If I went over here to the left, it would be negative 1, 0. If I went up, it would be 0, 1. And if I went down, it would be 0, negative 1. And SOHCAHTOA won't work if you tried it with this. So that's why we need to know those other definitions of sine, cosine, and tangent. The fact that the sine is y over r, the cosine is x over r, and the tangent is y over x. And remember, in the unit circle, the radius is always 1. So sketch the angle in standard position. Find the sine, the cosine, and the tangent of the theta. So what if theta was 540 degrees? Well, we're going to start here. It's positive 540, so I'm going counterclockwise. Now 360 would get me all the way around back to where I started. So I've definitely gone 360 degrees at this point. Plus, I'm actually going to go another 180 degrees, because 360 plus 180 is 540, and that's actually my terminating ray right there. I'm on a quadrantal. So what's my reference angle? Okay. My reference angle is 180 degrees. Now, what's the sine? Okay. The sine right here, since I'm on a quadrantal, I'm going to use y over r. Okay. What is the y value at this point right here? Okay. The y value is 0, so 0 over 1 equals 0. What's the cosine? Well, the cosine is x over r. At this point right here, which is where I am, the x value is -1. The r is always 1, so that's -1. And what's the tangent value? Y over x. Well, the y value is 0. The x value is -1, but 0 over -1 is undefined. Anything? No, it isn't. It's 0. Sorry about that. 0 over -1 equals 0. So there you go. Before we move on to the last concept, let me clarify one thing from that last example. I drew a terminating ray at 540 degrees just to make sure you saw exactly where we were when we went to 540 degrees. We were right here. We're on an axis. Well, that really isn't a reference angle right there. There really is no reference angle at that point because, in fact, we are on a quadrantal. And that's why you have to use these points and these definitions of sine, cosine, and tangent. Okay, moving on to the last concept that's on worksheet 3 or objective 3. Identify all the quadrants where the terminating ray for theta would make the equation true. All we're saying is we don't have to worry about the fact that it's actually 8 over 5. We're not really solving for anything. We're just identifying where could this possibly be. So this is saying theta has a tangent value that's positive. So where might it be? Well, it might be in quadrant 1 because everything's positive in quadrant 1, but it also might be in quadrant 3 because tangent is positive in quadrant 3. Now, sine theta equals plus or minus. Well, that just means it could be anywhere because there are 2 quadrants where sine is positive, but then there are 2 quadrants where sine is negative, so all 4 quadrants. Now, cosine squared theta equals 2 over 9. Well, this is kind of the same thing because this is the same notation as cosine theta quantity squared, and anytime you square anything, it's a positive answer. So if I square rooted it, it could have been positive, but it could have been negative. So we're back to all 4 quadrants. Now, cosine theta is negative 5/14. So the really important thing about this is the cosine value is negative. Where do we find reference angles that have negative cosine values? Well, it can't be in quadrant 1 because everything's positive. It could be in quadrant 2, or it could be in quadrant 3, but it can't be in quadrant 4 because cosine values are positive in quadrant 4.